The biggest secret in physics today is that it hasn't progressed in 100 years. There's this huge disconnect between the people who exist within the field of physics and the general population. The reason for this is if you exist within the field of physics, it takes so long to do anything that it always feels like something is happening. And if you don't exist within physics, you see a bunch of smart people constantly doing something and you assume that they are progressing. From both perspectives, you do not see that nothing has actually happened for 100 years. The last major breakthrough in physics happened at the turn of the 20th century. And before you get mad and start typing your comments, hear me out. Let me explain exactly what I mean so there is no confusion specifically about what I'm talking about. Firstly, I acknowledge that there is constantly research taking place by very many, very smart people all around the world, all of the time. I also acknowledge that there have been major accomplishments since 100 years ago. Fields like cosmology with Hawking, as well as the Large Hadron Collider, etc. With that out of the way, we can get into exactly what my observations have been about academia in general, but specifically through the lens of physics. Physics research is extremely inefficient, extremely bureaucratic, and functions far differently than most people expect. And as a result, I cannot help but thinking that our understanding of physics is underdeveloped or stalled from 100 years ago. Okay, let's dissect that claim. And the thing that's going to help us understand a lot of this, and the first thing we're going to analyze, is how research actually functions and how academia in general functions. Academia is a business model, no more, no less. That's it, regardless of whether you think that's good or bad, right or wrong, whatever romantic ideas you have about physics or research or studying the universe, that is what it is at the end of the day. As a result, the components of the system of academia behave as you would expect for a business model, which means that incentive structures come from where the money is coming from. So the way this looks is that universities need funding. Funding requires output. Output in an academic sense means research papers. So they need to be publishing. That's it. It essentially exists within its own bubble. It's all one massive show for each other, one massive circle jerk. And what that means is, as a researcher, as you within the system, your job is simply to write papers. That is it. That is your core objective. Write papers for the university. Publish or perish. What that means is you cannot be ambitious, you cannot take risks, you cannot even research what you want to research most of the time unless you are quite an established and trusted researcher. So you are stuck writing, and even they would admit this, for the most part, super niche papers on super niche topics about super niche things that no one will ever read, no one will ever understand, and actually even within the field of academia, it is not that relevant. Because they need to publish something, that is their job, remember that. Again, I'm not a critic, I'm not making a judgment call as to whether this is right or wrong, I'm simply informing you this, and this is my observation, this is how it actually functions. That is it. Because a lot of the time, people outside of academia kind of assume there's a lot of smart people all trying to do research into a field. They must be producing something, they must be developing. But I'm here to simply explain to you that's not necessarily true, because it all relies on the structure in which you use those people. A very intelligent, knowledgeable person doing research in something that is not going to yield results structurally will not yield results regardless of their intelligence or the time or effort they put into it. Another result of this systemic setup is that it becomes even more difficult to have out-of-the-box thinking. This is another misconception people have. People think that if you exist within a super intellectual field like physics, you must be thinking out of the box. But think about this from a structural point of view about academics in academia. The system is extremely rigid, and as a result, their thinking becomes extremely rigid. It's of no fault of their own, by the way. Put it into perspective like this. To be a researcher in academia, in physics, you essentially need to be locked away in a room, in a library for 15 years of your early adulthood. What that means is that there's a constant hierarchy structure, and you are always told things, and you are essentially put into a box, and you can only ever do things that you are told to do, and your thinking becomes extremely rigid, which is also why when alternative ideas come into academia, for the majority of the time, they are instantly rejected. Okay, now we have more of a general understanding about how academia functions. So where does physics come into this specifically? It's quite a unique way that it does, and I'll explain why. The first thing that you need to understand is that, for the most part, academia and research and development from academia is crushed utterly and absolutely 9 times out of 10 by the private sector, by corporations and by businesses. The reason for this is, again, simple human incentive structures and the structures in which both systems operate. Like we said, the incentives within academia is publish or perish. You're simply needing to output some paper. Whereas when you have competition within business, the incentive structures actually are tied to the work itself. Being more knowledgeable or developing research in a field actually relates to your profits. So you have incentive to do that. And when there is this kind of constant competition and testing and development between different people with incentives that all lead upwards in trajectory, you get massive advancements in fields like economics and applied mathematics and these kinds of fields. You'll see massive progress because there's actually a reason to progress. But right now we're in a period of history where physics as a field is miles ahead of engineering. The things that we can theoretically do in physics is head and shoulders above anything we could possibly build. Physics is unique in this sense because a lot of what we can test is extremely expensive, or at least a lot of the things that academics want to be testing is extremely expensive. It may even take collaboration from multiple countries, things like the Large Hadron Collider. But here is the crucial trap. Do not be fooled here. This does not mean that we are advancing. And this is something that Thomas Kuhn speaks about in The Structures of Scientific Revolutions, and I'm going to touch on this later. This is the standard narrative that you will be told right now. We made massive advancements very quickly in physics at the turn of the 20th century. So things like special relativity, quantum mechanics. This is referred to as a paradigm shift. Very simply, a paradigm shift is a complete rethinking of the very fundamental models of reality that we have within the field of physics we're talking about. We are essentially now, because of that, in a position where we have picked all the low-hanging fruit. So everything that was easy to know, we now know. So any more advancements that we make have to be extremely complex and extremely hard to test. That's the standard narrative. But there is a massive flaw here, and it's the same reason that people think that scientific progress progresses linearly with time. So the more time we have as a species, the more advanced we get. That's not necessarily true, because each paradigm is essentially its own set of rules. It's its own model for reality. Nothing is objective, and it doesn't need to build off each other necessarily. The people before Einstein, by the way, thought exactly the same thing. At the end of the 19th century, people essentially thought they had finished all of physics. Physics was all basically done, and there was just one or two small, stubborn problems that they couldn't solve, combining Maxwell's equations with standard models of classical mechanics. And that's exactly the same thing that we have today. We think we've picked off all the low fruit. We know everything there is to know about the universe. There's just one or two holes that are quite stubborn problems, relating gravity to quantum mechanics, for example. It's just that one thing that is just really stubborn and we haven't been able to achieve yet. And by just pushing deeper and going more into detail about our current models, our current paradigm, we must be able to figure out a solution for this thing, because we know everything, right? So if we know everything, then clearly if there's some hole in our knowledge, then using our current existing knowledge must be able to explain that thing, because we know everything there is to know. That's the underlying assumption. I really want to drill this point forward. Do not mistake complexity with knowledge. Take this pen, for example. This pen I can describe in as much or as little detail as I want to. I use this example all the time, but the level of complexity of this pen is arbitrary. This pen could be modeled as a single mass in space, just a point. This pen could also be modeled if I describe every single of the billions of little particles that exist within the pen. Both are equally valid models that exist in their own paradigm, but they're different levels of complexity. And the key thing is, I choose how complicated I want to make this pen. When we exist within a paradigm of science, you can look as deeply as you want into this pen, but that doesn't necessitate that we learn anything about the table. My message in this video is not that I have the answers, or that I have some kind of secret knowledge, or that everything that people do is stupid, or that we should be 1,000 years more advanced than we are. My simple purpose in making this video is to relay my observation that solving problems is often far more dependent on the structures we actually have in place to tackle those problems than the complexity of the problems themselves. In other words, there are huge inefficiencies in the way we do research. That's it. I'm not passing judgment. I'm not saying that individual researchers do not want to solve things. I'm simply saying there are obvious structural flaws in the way we do research. Subscribe to keep seeing more content like this. I don't personally know anyone else that has made any video on the topic I just did. Like the video so that more people can see it. That's all I have to say for now. Thank you for watching and have a nice day.